Section 9.4 is graphing and writing equations of ellipses. And you probably know what an ellipse is, or maybe you don't, but an ellipse looks, something like an elongated circle. It can be horizontal, or it can be vertical. Okay, so remember, with every section, you're going to have important characteristics. So I would pause the video and jot down. I'm going to highlight the ones that are going to be for sure important for you to note. So you're going to want to know foci when you're talking about an ellipse, vertices, covertices, and the center. The major and minor axes are good to know, but I definitely won't test you on those concepts. So at the very least, write down the underlined words. So an ellipse is where the set of all points P such that the sum of the distances between P and two fixed points called the foci is constant. That probably makes no sense. I'm going to give you a visual here in a second. But first I want to make sure you understand what foci are. So with the parabola, remember we talked about having a focus point. With an ellipse, foci is just plural for two focus points. So you have two fixed points and they're called foci. And they're inside the parabola always. I'm just going to kind of make up where those two foci might be. Always in an ellipse. Your vertices then are the point at which the line through the foci intersects the ellipse. So if you have a horizontal ellipse, as this one is because it's stretched horizontally, then your vertices are going to be as if I just cut the thing in half, always going through your foci. And your vertices are going to be those points right there. Your major axis is that line that I just drew. So it's a line segment that joins the vertices. The center is literally the center, of course, of the ellipse, but it's the midpoint of the major axis. So the midpoint of this major axis, of course, would be, right there. The covertices are the point of intersection of an ellipse and the line perpendicular to the major axis. So this line here, which is, by the way, my minor axis, intersects my ellipse at those points, and those are called covertices. So they're always in the non-elongated direction. And then the minor axis is that line segment that joins the covertices. So minor and major axes probably make sense, but nothing I'll test you on. So your important characteristics for an ellipse are, characteristics, I couldn't fit that all in there, are foci, vertices, center, and covertices. Okay, now here I'm going to make sure that the definition of an ellipse makes sense. So an ellipse, of course, is a member of the mathematical curves called conics. And if you have an ellipse, again, this one's horizontal because it's stretched in the horizontal direction, you can take any point on the ellipse. Okay, so I'm going to look at this point that they have highlighted here. And there will be, if I take this distance to the focus point and this distance, shortest distance, of course, to the other focus point, this is focus 1. I guess it's not really labeled, is it? Focus point 1 and you have focus point 2. That distance, so let's say this is A units and this is B units. A plus B, I'm just going to make this up, let's say it equals 10. Every point on the ellipse, the distance to the focus points, the sum of it will always equal 10. Okay, so if I take a different point anywhere on the ellipse that I want, I'm just going to kind of randomly select one. So let's say I do this and I take this distance and this distance, and let's say it's, A and B again, that will total 10. Okay, I can take a different point anywhere I want on the ellipse. So let's say I pick this point. That distance and that distance will total 10. So any point on the ellipse, the distance, the sum of the distances to the two focus points will always be a fixed amount. How cool is that? All right, now here's your equations. They are totally different from a parabola. This is the standard equation of an ellipse with the center at the origin. Okay, so the center is at the origin. These are not shifted. you're going to have two ellipses. Okay, so if you have a horizontal ellipse, I'm just going to draw a really drastic horizontal ellipse here. You're going to have x squared over a squared plus y squared over b squared equals 1. Okay, now if you have a vertical ellipse, which of course is elongated in the vertical direction, please note it's the same equation, but the a squared and the b squared just flip spots. Okay, so a is always going to be larger than b. In fact, I'm going to highlight that right down here. Okay, a is always larger than b, and they're both obviously more than 0 because you can't divide by 0, and it will never be negative because it's a directional thing, a distance thing, excuse me. So if a squared is, if a is always bigger, a squared is going to be underneath x squared, it's going to be bigger. If a squared is underneath y squared, that's going to be the bigger. So basically, whichever denominator is bigger, that's going to tell you what your a, which one is a, and the smaller one is always going to be b. Okay, if I know a squared, I can square root that number to just find a. Now, if it's a horizontal ellipse, I know that because the larger number is underneath x, hence it's going to stretch further because it's larger in the x direction, making that horizontal. If the larger number is under y, it's going to stretch in the y direction further, hence making it vertical. Okay, so make sense of this. So if it's horizontal, my vertices are going to be in the horizontal direction, hence if it's centered at the origin, my vertices are going to be on the x-axis, and they're going to be a units from the center, from the origin, excuse me. So plus or minus a, so it's going to be 5 units to the right, 5 units to the left. From the flip side of that, if it's vertical, it's going to be a units in the y direction, so it's going to be 0 plus or minus a. And then your co-vertices are going to be b units in the opposite direction. So here my co-vertices are on the y-axis because my vertices were on the x-axis. And for a vertical ellipse, my co-vertices are on in the x direction because my vertices were in the y direction. And last but not least, very important down here, is how you find your foci. Okay, so the foci of an ellipse lie on the major axis a distance of c units from the center. And how you find that c is by using this little formula, c squared equals a squared minus b squared, and yes, looks very much like the Pythagorean theorem, right? So you use that. If you know a and squared and b squared, of course you can figure out c squared, and then you can find c. And I will do some examples in the next video, of course, encompassing all this. So pause the video, write down these equations, because remember, you can use your notes on the test.